Hello everyone, welcome back to the Backend Masterclass. In the last lecture, we've learned how to use Docker Network to connect two standalone Docker containers by name. Today I'm going to show you how to use Docker Compose to automatically set up all services in the same Docker network and launch them all at once with a single command. Okay, let's start. First, I'm going to create a new file, docker-compose.yaml, at the root of our project. There are a lot of things you can configure with a Docker Compose file. You can read all about them in the documentation by going to docs.docker.com. Open reference, Compose file reference, version 3. On the right-hand side menu, you can see a list of different syntaxes. In this video, I will show you some of the most important ones that we usually use. Here in the center of the page, we can see an example Compose file. Basically, you define the Docker Compose version, then a list of services you want to launch together. In this example, there's a Redis service, a PostgreSQL service, and some other web services for voting and computing the result. Now I'm just going to copy the first two lines of this example and paste them to our docker-compose.yaml file. Note that a YAML file is very sensitive to indentation. At the moment, the file is using 4 spaces indentation, but I just want to use 2 spaces instead. So I'm going to click on this button, select indent using spaces, and choose 2 as a tab size. Okay, now if we press enter, we can see that it is nicely indented with 2 spaces. Next, we have to declare a list of services we want to launch. The first service should be PostgreSQL. For this service, we're going to use a pre-built Docker image. Hence the image keyword, followed by the name and tag of the image, which is Postgres 12 endpoint in this case. Now we will use the environment keyword to specify some environment variables for the username, password, and DB name, just like what we did in the GitHub CI workflow. First, let's copy the Postgres user variable. The syntax is a bit different. We have to use the equal operator to assign the value. Similarly, I'm going to copy the Postgres password variable. And finally, the PostgreSQL variable. Alright, next step, we will declare the API service, which will serve all API requests to our simple bank. For this service, we should build its image from the Golang source. So under the build keyword, we specify the context to build the image. This dot means the current root folder. Then we use the Dockerfile keyword to tell Docker Compose where to find the Docker file to build the image. In this case, it's just the Docker file at the root of the project. Next, we should publish the port ATST to the host machine, so that we can call the SimpleBank API from the outside of the container. One of the most important things we must do is to tell the API service how to connect to the Postgres service. In order to do that, we will set one environment variable, dbSource. As we have seen in the previous lecture, setting this environment variable will override the value we declare in the app.env file. And since all services in the Docker Compose will run on the same network, they can communicating with each other via name. Therefore, here in this URL, instead of localhost, we will use the name of the Postgres service. And that's basically it. The Docker Compose file is completed. Let's try to run it. If you have the latest Docker CLI on your machine, all you have to do is to run Docker Compose up. Then Docker Compose will automatically search for the docker-compose.yaml file in the current folder and run it for you. As you can see here, before running the service, it has to build the Docker image for SimpleBank API service first. Then after the image is successfully built, Docker Compose will start both the Postgres and the API service at once. In the logs, we can see whether it comes from which service by looking at the prefix of the line. It is either Postgres 1 or API 1 in this case. Now if in another terminal tab, we run Docker images, we can see a new SimpleBank API image. Basically, the image name is prefixed with SimpleBank, which is the name of the folder containing our Docker file, and is suffixed in the name of the service itself, which is API. Now let's run docker ps to see all running services. There are 2 services, SimpleBank Postgres 1 and Simplebank API 1. Both of them have the Simplebank prefix followed by the name of the service. Now if we go back to the Docker Compose tab and scroll up to the top, we can see clearly here that a new network Simplebank default is created before the two service containers are created. Now if we try to inspect the Simplebank default network, we can see that the two service containers are actually running on this same network. That's why they can discover each other by names. Alright, now it's time to send some real API requests to see if the service is working well or not. As the new database is completely empty, I'm just gonna send the create user API. Oops, we've got 500 internal server error. And the reason is relation users doesn't exist. Do you know why? Well, that's because we haven't run DB migration to create the DB schema yet. To fix this, we have to update our Docker image to run DB migration before starting the API server. It will be done in a similar fashion as what we've done in the GitHub CI workflow. We will have to download Golang migrate binary to the Docker image and use it to run the migration. So I'm going to copy these two instructions and paste them to the Docker file in the builder stage. First, we have to run this curl command to download and extract the migrate binary. And then I'm going to move this second command to the run stage, where we will copy from builder the downloaded migrate binary to the final image. We have to change the path of the original migrate file to /app, because that's the working directory in the builder stage when we download and extract the file. Then I'm going to put this file in the same workdir folder in the final run stage image, which is also /app. Next, we also have to copy all migration SQL files from the db/migration folder to the image. So copy db/migration. I'm going to put it in the migration folder under the current working directory. Now, one thing we must do is to install curl in the builder stage image, because by default, the base unpy image doesn't have the curl pre-installed. To do that, we just have to add a run apk add curl instruction here. Finally, we have to change the way we start the app so that it can run the DB migration before running the main binary. I'm going to create a new file, start.sh, at the top of our project. Then let's change mode this file to make it executable. This file will be run by bin/sh because we are using unpy image, so the bash shell is not available. We use set-e instruction to make sure that the script will exit immediately if a command returns a non-zero status. First step, we will run DB migration. So we call the app/migrate binary, pass in the path to the folder containing all migration SQL files, which is /app/migration. Then the database URL, which we will take from the DB source environment variable. So here I just use $dbSource to get its value. Let's also use the verbose option to print out all details when the migration is run. Finally, the app argument is used to run migrate up all migrations. After running migrate up, we will start the app. All we have to do in this step is to call exec $at. It basically means takes all parameters passed to the script and run it. In this case, we expect it to be /app/main as specified in this CMD instruction. To make it work, we will use the entry point instruction and specify the /app/start.sh file as the main entry point of the Docker image. Keep in mind that when the CMD instruction is used together with the entry point, it will act as just the additional parameters that will be passed into the entry point script. So basically, it will be similar to running /app/stats.sh with /app/main as a second argument. But by separating the command from the entry point, we have more flexibility to replace it with other command at runtime whenever we want. You can read more about this in the Docker documentation page, in the CMD instruction section. Okay, now the Docker file is updated. Let's try to run Docker Compose again. But first we need to run docker-compose down to remove all existing containers and networks. And we should also remove the SimpleBank API image because we want to rebuild the image with the new DB migration script. Okay, everything is cleaned up. Let's run docker-compose up again. It will take a while to rebuild the image. Oops, we've got an error. Start.sh, no such file or directory. Oh, that's because I forgot to copy the start.sh file into the Docker image. So let's do that now. Here in the run stage, we just need to add one more instruction. Copy start.sh dot. And that's it, we should be good now. Let's run docker-compose down to remove all containers. Run docker-rmi to remove the old SimpleBank API image. And finally run docker-compose up to rebuild and relaunch everything. This time, looks like the DB migration script was run. However, it was still not successful. The service exited with code 1. And in the log, we can see the error, connection refused. The app cannot connect to the database to run DB migration. That's because it takes some time for the Postgres server to be ready. But the app tried to run the DB migration immediately when it starts. And at that time, the Postgres server was not ready to accept connection yet. So to fix this, we have to tell the app to wait for Postgres to be ready before trying to run the DB migration script and start the API server. Now, although in the docker-compose.yaml file, we can use the depends on instruction to tell docker-compose that the API service depends on the Postgres service. This only makes sure that the Postgres service will be started before the API service. It doesn't ensure that the Postgres is in ready state before starting the API service. You can read more about this behavior in the docker-compose documentation page. Just search for depends on in this page. Then you can see here, they listed several things to be aware of when using the depends on instruction. If we want to wait for a service to be ready, we should follow this link to know how to control the startup order. There are several tools that has been written to solve this problem. But the one we should use in our case is the sh-compatible wait-for script, because we are using an ARPy-based image. Okay, so here is its GitHub page. Wait-for is designed to synchronize services like Docker containers, and its usage is pretty simple. We just need to run wait-for and pass in the host and port URL we want to wait. Here's an example. It's basically waiting for the web page fecode.com port 80 to be ready before executing the echo statement. So what I'm going to do is open its latest release version and click on this link to download the script. The file will be downloaded to my downloads folder. So I'm going to open the terminal and copy that file to the root of our SimpleBank project. I will rename it to wait-for.sh to make it clearer about the file type. Note that this file is not executable yet, so we should run change mode +x to make it executable. Alright, now back to our Docker file. I'm going to add one more instruction to copy the wait-for.sh file into the final Docker image. Then in the docker-compose file, we should override the default entry point and command so that it will wait for the Postgres service to be ready before trying to start the API service. Let's add entry point here, and its content should be /app/wait-for.sh. Then the host and port to wait for should be Postgres 5432, followed by 2 dashes. Then finally the start.sh script to run after the Postgres server is ready. Now you should know that when the entry point is overridden like this, it will also clear out any default command on the image, meaning that the cmd instruction we wrote in the Docker file will be ignored. So in this case, we have to explicitly specify the command we want to run in the docker-compose.yaml file as well. We use the command keyword for that purpose. And the command we want to run is simply /app/main. And that will be it. I think now we have everything we need for the app to launch successfully. Let's try it one more time. First, let's run docker-compose down to remove all existing containers. Run docker-rmi to remove the SimpleBank API image. and finally run Docker Compose up to rebuild and relaunch the services. This time you can see that the services are started in order. First, the Postgres service will run, and only when it is ready to listen for connections, then the API service will start running the DB migration. Therefore, the migrations will run successfully. First the init schema migration, then the add user migration. Finally, the API server was started successfully after the DB migrations. We can see the gin log saying that the server is listening and serving HTTP requests on port 8080. So let's open Postman to try it. I'm gonna send this same create user request as before, but this time the request is successful. A new user is created. Awesome. And with this, I'm gonna conclude today's lecture about Docker Compose. Now you know how to use this powerful tool to launch multiple services at once with specific startup orders. Thanks a lot for watching, happy learning, and see you in the next lecture.